Today, I'm trying to show you the difference between having only two solutions for something and having all the solutions for something. We're going to go back in time to when we graphed sine. You do not have to draw this, just pay attention. Do you agree that sine looks something like that? It's a wave. All right. Okay, so if you look at sine, then you say, what if I want sine to be equal to 1? Well, I know you're used to doing it this way, where, you figure out which quadrantal it is, but I want to remind you, sine is equal to 1 when its height is 1. But wait, it appears that it happens more than once. In fact, if I had drawn this perfectly straight, you'd see that it keeps on hitting it over and over and over. You see sine is 1 here, sine is 1 here, and if I kept the graph going, it would keep touching forever. It even touches back over here at 1. All right, so how come I only ask you for one answer? Because usually I'm asking for the answers between 0 and 2 pi. Do you get that's just a little window, and in that window, that's the only one answer we have. But there's actually infinite answers if I wanted to keep going. And how far apart are they? Ooh, do you remember this thing called the period? How far apart are they? Sine's period is what? Forgotten some stuff. Nope, not pi over 2. That's what you count by. That's what these little marks are. Nope. That's the range. It goes from -1 to 1. The period. How far? Yep, you remember? 2 pi is correct. So, if I have an answer and I want to get another answer and even another answer, I just have to keep on going over 2 pi. So, when I say later that we're going to add plus 2 pi to our answers, that means you could take your answer and add 2 pi to it, and you get another answer. Does that make sense to you? You can just keep going over, and I can find another answer over here. I'll do it. And then the blue line goes like that, and see, they touch again right there. And you just keep adding 2 pi, and you keep on getting another answer. So if you keep adding 2 pi, any number of times, that's the k, you got to learn how to do plus 2 pi k on the more complicated questions. So at the end of your worksheet today, they changed the directions from, give me the answers that are between 0 and 2 pi, which would be like this window here, the green window. They changed the directions from between 0 and 2 pi to give me all the answers. And then you just have to add plus 2 pi k on the end of your answer. So I'm going to finish this one. If sine theta equals 1, that means the y is 1. That means that I'm right there, and that means I'm at 0, 1, and that's a spot where y is 1. Do you agree with me so far? And so then this answer was pi over 2. And that's the one answer that's between 0 and 2 pi. See, that's right here at pi over 2. That's the one answer I had that was in this green window here. But if I wanted all the solutions, I'd have to put plus 2 pi k. So instead of just writing pi over 2, I got to write pi over 2 plus 2 pi. And k is just a constant. It means you could multiply it by 1, multiply it by 2. You could multiply it by 7. You could go over 2 pi 7 times if you want. So there you go. That's it. For today, that's the only thing that's really new, is if I say, give me all the solutions. You have to take whatever answer you would have had and add plus 2 pi k. Because that tells you that you could keep going over 2 pi and keep getting answers over and over and over again. All right. So to see if you really got that, I'm going to give you one that is just pretty normal, other than the fact I want you to find all the solutions. So therefore, slap on that little ending I just told you. So you'll be able to do this the normal way, except at the very end, you slap on plus 2 pi k, because I want all the solutions. So again, do it the same way you always have. Try to figure out where sign is negative, cross off the ones where it won't work. I'm going to pause for a second. Let me give this a shot. And this isn't the only thing I'm teaching you today, but it's the only new thing. And then we're going to practice some of the other tricky factoring ones. All right, so by now you have limited it down to only the places where sign is negative. So you should have crossed off this and this. And then you should draw some triangles, get some angle answers. Would you please check with the kid next to you to see what they think? So I've drawn my triangles. I really only have to draw one of them really carefully and nicely, because then that'll tell me what I'm in, if I'm in pi over 4s or pi over 3s or pi over 6s. So sine is opposite over hypotenuse, and then this must be a 1, but most common mistake in circle trig, check and see if you put a negative 1 there. So easy to forget that. And it actually doesn't change your angle answer, but it, that's easy to forget. It is negative. All right, so then what's across from the root 3? That's a 60. But can I say 60? No. Pi over what? Pi over 3. But it's a bunch of pi over 3s. 3 pi over 3s to here, that makes 4 pi over 3. And I'm not done yet. Then I'm going to go over here to 5 pi over 3. And just checking to make sure I didn't screw it up, one more would make it 6 pi over 3, which would be 2 pi, which makes sense. Just making sure I was in the right spot there. And then, oh, can you see how easy it would be to forget? Plus 2 pi k. Plus 2 pi k. And why does that have to be there now? Because there's more answers. You can just keep going over 2 pi, and you'll get more and more and more answers. Why didn't we ever have that before? Because before, the problem's always said between 0 and 2 pi, which implies you got to stop at 2 pi. And that was theta, sorry. So let me show you again what's happening. Sine is some negative decimal. It can't be lower than -1 or it wouldn't even exist. So here's sine, and it just keeps going like this and that. And sine is some negative decimal. So I'm going to draw a line through like that. And it appears that it hits there and there inside of our window. Our window is between 0 and 2 pi, and that's where we're just supposed to look at first. And those are our two answers that we got. If you've ever thought of it that way. But that was 4 pi over 3 and 5 pi over 3. And if I wanted, I could go get more answers by going leap ahead 2 pi. Boop. There's another one. Leap ahead 2 pi from here. Boop. There's another one. So that's why you say plus 2 pi. Yes?
I did negative. That was like negative pi over 3 plus 2.
No, you can't give negative answers. I get what you're thinking, but you always start with the two angles that are between 0 and 2 pi, and then you add 2 pi k to them. We don't use negative angles in this unit. We do in inverse trig, but not this unit. All right, if you have any more clarifying questions, I'd be happy to help you, because that's the big thing for today. Is there any other part of that you don't get? So if I say all solutions, you add plus 2 pi k. Because it'll just move you over on the graph. It'll move you like from here over to here, and it'll keep getting more and more answers. You can go another 2 pi, and there'll be another answer. Okay, good enough on that. Now, a whole bunch of things to review. Here's another easy one, except I want all solutions. So that should just tell you, just add the 2 plus 2 pi k onto it. For tangent of theta equals 1. This is not a quadrantal. A lot of people think, oh, yeah, it's got a 1, and if there's 1s and 0s, it's probably a quadrantal. It is not, because you can have opposite and adjacent be both 1. another way to think of it is you'd never find one of these quadrantals where the y and the x, that's what tangent is, are 1 and 1. So it is not a quadrantal. It's some other spot. Tangent is positive, so it could be here, and it could be here. Not here, not there. These two quadrants are the only spots where it could be positive. Don't forget, we're finding all solutions. So I'll use the dice of destiny to ask somebody to explain this to me. And it is going to be in the 5th row, the second person. Rissy, that is you. Can you tell me how to do this? Like, I got a 1 and a 1. Where do I put them? Opposite and adjacent. This must be root 2. What does that tell you? It's a 45. And then that tells you to use pi over 4. And then there's another answer. It's 4 pi over 4 is to there, plus one more, 5 pi over 4. So far I'm right, but row 5, person 1, Ainsley, that's you. Can you explain what I do now to get the final answer? And why do you have to do that? Because I said all solutions, and if you go over 2 pi k, there'll be another solution. I'm going to show you a picture of this one too, just so you can picture it. This is tangent, and it does this. I thought there's only 2 solutions. Well, there's 2 solutions if I just go in these first 2 spots, because that's between 0 and these first 2 would be between 0 and 2 pi. And it's where is tangent equal to 1? Well, there's a line that goes through like this. And see, my first 2 answers were here and here. But if I wanted to, I could keep on going and keep on making tangent graphs and keep on getting answers infinitely by going 2 pi over, 2 pi over. Okay, I think you get the idea. Okay, so you're in the middle of the test next week, and you'll need your sheet for this one. It says 2 parentheses. I'm going to write it in a darker color so it's easier to see. 1 minus sine squared plus 3 cosine plus 1 equals 0. Whoa, complicated. So what's the problem here? Like, why can't I just start factoring it right off the bat, Madeline? What's wrong? Why can't I factor it right away? Look here and here. There's 2 different functions. Let's fix that. Dominic, do you recognize this one? Do you know it? It's on the sheet. There's only one place where you see sine squared on the whole sheet. Got to do a little rearranging in your head. Here's the fact you're seeing on the sheet. I know. Sine squared plus cosine squared equals 1. That's the fact. Can you rearrange it in a way that'll allow us to swap it out? Hint. You want 1 minus sine squared. So we're going to yeah. And then, what does it say? Exactly. So you can replace 1 minus sine squared with cosine. All right. So that gets replaced with cosine squared. Everybody do that, and now it'll factor. You see how factoring just is like a little part of this problem? That's why it was so important at the beginning of the year, in the top 20, that you had to get all those down, because there's like 6 different kinds of factoring on there. Compare your factoring to the kid next to you and see if you guys factored it the same way. 2 cosine plus 1 and cosine plus 1. You just do it one step at a time. These two make your 2 cosine squared. And then they had to be pluses because there was only pluses in the problem. Then I had to multiply to 1, had to be a 1 and a 1. So it falls into place pretty quick. And then you got to check it to be sure you're right. This makes 1 cosine, this makes 2 cosine, put them together, it makes 3 cosine. Yay, it worked. But how come we're not done? Lauren Sabins, can you tell me what we're going to have to do next?
You want to find the x's by setting equal to 0.
Yes, we're going to have to set each of them equal to 0. And then they have a little circle trig question built in. Go ahead, finish this one. I'm not going to do too many more. We have practiced circle trig so many times now that this should just be like boom, boom. Easy peasy. Lux, could you do the one on the left?
The one on the left. You can change 2 cosine, I think.
Yeah, we got it. We got that. I think here. Maybe I'm not.
You can also- you
We
can
do the
also
red
change-
one.
Oh, sorry. You can do, yeah, you can add -1 on both sides, divided by 2, so it's cosine theta equals 1/2.
7 equals -1. Hold on. Divide by 2. Divide by 2. Yup. Cosine theta equals -1/2. Now what?
And then you can do circle trig to figure out what it is.
All right. ASTC. Tell me which quadrants I'll be in.
The top right and top left.
All right. So, not sure. I'm having a hard time processing lefts and rights right now, but I think it's those. No, wait. I think it's. Yeah, cosine's negative, so it has to. So, did you mean these two?
Yeah.
Okay, good. Then I'm going to draw my triangles in there. Cosine is adjacent and hypotenuse, and that's a square root of 3. And then let's just do that one well. So can you finish it from there? What angle would that have to be?
Pi over 3.
All right. Now, you're right that it's pi over 3, but remember I'm here, which is way bigger than pi over 3.
So then you add pi over 2, so you get 4 pi over 3.
Nope.
Pi over
It's a whole bunch of pi. It's pi over 3. You were right on that in the first place. So this is pi over 3. But to get here, it needs to be a bunch of pi over 3s. You know? 1 pi over 3.
Oh, yes, it would be 2 pi over 3.
Just 2 pi over 3. Okay. And then finish it to get to this spot here. It's even more pi over 3s. This would be 3 pi over 3.
So it would be 4 pi.
It'd be 4 pi over 3. There you go. But what if mean old Mr. Server said all solutions? Maren, do you know how we would add?
Then you'd add the 2 pi k.
Yes, plus 2 pi k. I didn't say. And if I don't say, that means you got to give me all the answers. Like, think about it. No math teacher has to say, give me all the answers. That's assumed on a test that you give me all the answers. All right. Now, it's likely it's going to say, give all the answers to just remind you that you got to put plus 2 pi k. Okay, here's one more like that. I'm cutting down how many practice problems I was going to do. So please respect that and try really hard in this last one that we do together. And then we'll start our homework and you'll have some work time. Secant squared plus 2 tangent equals 0. Something can be swapped off the sheet. Yes?
Would you do anything with the other answer on the last one, the cosine equals -1?
Yes, we aren't going to finish that question. I get what you're saying. Thank you very much. This also had an answer. And that would be a quadrantal. So thank you for reminding me, but I want to move on because I'm feeling like I don't have too much more of your attention time left. So we're going to do one last problem together, and this one we will finish all the way. So, Winston, why can't I just do it the way it is? Factor it right now.
Difference
Functions.
Functions.
Okay? So then what are you thinking about swapping?
Always secant.
Yep, the secant squared. Look on the sheet and see what you could swap that for.
Tan squared plus 1.
Yes. And why do I know that's right? Because this got tangent. And the other one's got tangent. And then, if you rearrange this properly, it will factor. Now, you know this stuff is tough. When I added in, and it is like the first time all semester that it wasn't like a critical end of the quarter time or whatever, where I'm adding in an extra work morning, where if you can come in, you want extra help next week on Tuesday and Thursday, you can come in the morning and get extra help. That's double the amount of help I normally give in the morning. Why? Because this is tough stuff. And if you're struggling, I don't want you to have to wait all the way to Thursday to get help. Turf, do you know what order I should put this in before I try to factor it?
Tan squared
Yep,
plus 2 tan
yep,
plus 1.
nice. Morgan, can you start the factoring process for me? Just what goes here and here. If I had 2 tan, there'd have to be a 2 right there. There isn't a 2, so it's just regular tan and tan. I know you're seeing this one, but that's not in front. And the way you could tell for sure is you just multiply this times this, and you see if it's that. And I don't need a 2, so you're really close. And now, who haven't I picked on yet? Bodie, what symbols should I put here and here?
Plus and plus
And the numbers?
1.
Yep, because 1 times 1 is 1. Now, this is kind of one of the nice ones. It's got the same exact thing twice. So you, of course, don't have to do it twice because once you've done it, you've done it. And then I need to try to figure out if this thing is like a quadrantal or what it is. So first thing I do is set it equal to 0. So tangent theta equals -1. And now, Kaylin, is it a quadrantal?
No.
No. If tangent's negative, can you narrow down what quadrants I can or can't be in?
You can't be in quadrant 1 and 3.
Nice, those are the ones where it would be positive. So now I'm going to draw a triangle here and here. Let's focus in on this one. Can you tell me how to do this?
Yeah, you have -1, or opposite over adjacent, so you have -1, 1,
Oops. You're not wrong. A -1 and a 1, but I got to put the -1 down there. Okay, keep going.
square root of 2.
Nice. And then theta, a common wrong answer is the kid goes, ooh, pi over 4. What's wrong with the answer pi over 4?
3 pi over 4.
Because it's all the way over here. So it's a whole bunch of pi over 4, so 3 pi over 4. And then I hope I've made you nervous about like, should I leave it that way? Because why?
Because it's 2 pi, okay?
Yes, if I wanted all solutions, and I never said, if I don't say that I only want you to limit between 0 and 2 pi, then you should put it. And then if I say only between 0 and 2 pi, we just have one more. Kaylin, you've been doing great. Can you finish this thing? What's over here?
Be -1 for opposite and then adjacent.
We don't even have to do all the sides. I know it's pi over 4, so
7 pi over 4.
yes, this spot would be 7 pi over 4, and then plus 2 pi k. You guys are doing really hard math here. If you grabbed a random person off the street in Excelsior and offered them $1,000 to do that problem without any help, it'd be like 1 out of 1,000 people could do it. But you're one of them. That's cool. All right, so notice the process. We started with something that couldn't factor because it had two different functions. Then we swapped it out for something on the sheet so it would factor. Then it factors. Then you have to know how to break that into circle trig. Then you have to remember to add plus 2 pi k at the end. That's the brand new thing for today. All right, there is a worksheet. I am having you cut off more than half of the problems. That keeps it reasonable. You have a fair amount of work time still. And let's do number 1 together. We are doing the odds only. So we will do number 1, 3, 5, 7, 9, etc. But, so go ahead and cross off all the even ones and cross off number 9 because I think it's too complicated. So cross off all the even ones and cross off number 9. Then here is number 1. And the first thing I noticed about this one when the kid read it to me last hour was, I was like, is there no squared? No, there's no squared. So, Winston, tell me how to start. I'll come back to you for step 2. Turf, tell me how to start.
You do -2 to get.
I get what you're thinking. You're thinking of factoring, but that's only when they're quadratics, when they're like squared. So this isn't squared, so don't subtract 2. Maybe you should add 1. All right, yep. You would, if you would have done the other thing, you would have looked at it and you would have been like, I can't factor this. So I'm just trying to save you some time. All right. Bridger, what's next?
You
Trying to get,
into 3/6.
so you're going to divide by 6. And then reduce that, Bridger.
1/2.
Does this look like a circle trig question to you? Good. Tell me which quadrants I can or can't be in.
You can do A and S for that too.
All right. Sign is positive, so you can do A and you can do S. Yep. All right. Xavier, tell me where I should put the 1 and the 2 from this angle's perspective using like opposites, adjacents, and hypotenuses.
You put the 1 on the right
Okay,
and 2 on the hypotenuse.
good. Third side square root of 3. What's the one that's across from the 1 here? What is this angle? Pi over what? Pi over 6. That is one of my answers, unless, now this is the part where we have to look at the directions. Does the directions say they only want between 0 and 2 pi? Or does the directions say we want all solutions? If you look at the top, aha, it says between 0 and 2 pi. So you don't just automatically slap on a plus 2 pi k. It only wants 2 answers. So now we just do the other one. TiVo, how many pi over 6s will this be? Yep. So pi over 6 and 5 pi over 6. If it had said all solutions, you'd say plus 2 pi k. It does not. All right, there's number 1. Number 3, remember we're doing odds. Number 3, Maren, what's the problem with having secant and tangent in the problem? They're different functions. Good. So how am I going to start? You can. There's 2 different things you could tell me on how to start. What do you think? Yes. We're gonna. Well, actually, it's a minus. Is it a -1 or is it a +1?
It's +1.
It's +1. Thank you. I must have wrote that down wrong. Yep. And then I'm going to -1 from both sides. Because you want to set it equal to 0. That's, I can tell that's what you wanted to do first. Then what's the second thing you'd need to do?
Set the functions equal, so it'd be, you could take tan x -1, or no,
Always take the squared one
okay,
and take it out. So then what am I going to put in instead of it?
tan squared +1.
Yes. The fact off the sheet is the one with the tan is what you seek. Tangent squared +1, the secant. So then Does the minus one and the plus one really cancel? Yes, it does. So don't freak when it doesn't look normal. It must factor. The plus one and the minus one cancel off. I got tangent squared plus tangent. I know there's usually a number last, but you can still factor this. Ainsley, do you know how to do it? Yeah, take out a tangent. We're factoring out a tangent because they both have a tangent in them. And then technically that means you're dividing by tangent on both of them. And I have tangent. And tangent over tangent is a 1. Man, you have to be like an algebra ninja to be able to handle these problems. So many little algebra things you have to know, like factoring, again. But then, each of these can be set equal to 0. And one of these is going to be a quadrantal. I know because it says 0. And there's no way to have 0 side on a triangle, so then it must be a quadrantal for this one. And I think the other one is not a quadrantal. All right. You might end up with 3, sometimes even 4 answers to these problems. Now, especially warning on number 7, it is not impossible, but it's a challenge. So if on number 7 you try it for a minute and you're like, oh, I'm stumped. Nothing wrong with looking at the key. Just learn how to do it. But 7 is assigned. Just fair warning that you might want to check the key for like a first step. And that's all I got for you for today.